Today it's a great privilege to have Emily Nicholson with us from the University of Melbourne. Emily's a Professor of Conservation Science at Melbourne. Before that was at Deakin, and before that at the University of Melbourne. So we met 2012, I think, when Emily returned from Imperial College, where she had a Marie Curie Fellowship, and then stint at Melbourne Uni, Deakin, and now back at Melbourne. But Emily did a PhD here with you back in the day, and so it's a joy to have you back with us. I'm just going to quickly give an acknowledgement of country and move on to Emily's presentation. So here at the University of Queensland, we acknowledge the traditional owners and their custodianship of the lands on which we meet, and we pay our respects to their ancestors and descendants who continue cultural and spiritual connections to country. And we recognise their valuable contributions to Australian and local society. All right, I might hand over to Em, and really looking forward to you.
Yeah. So apologies to anyone who was at EFA or ICCB. There's a little bit of recycled stuff here, but mainly because it's what I'm thinking all about. And so what I'm going to talk about is some work that I've been undertaking, focusing a lot of my energy on over the last 2 years, which is working with the UN Convention on Biological Diversity on the indicator framework for monitoring progress towards the Montreal Global Biodiversity Framework. I'll explain what that is in a moment. And so I was on an expert group on indicators, and now I co-chair their advisory group on the global review of progress. And I also co-lead the Registered Ecosystems Thematic Group in AECN's Commission on Ecosystem Management, which is where a lot of the sort of ecosystem work that I've been doing takes place. Okay. First, I'd also like to acknowledge the country that we're on today, the Yagara and Turrbal people, and also where most of my work has taken place, which is on the lands of the Wurundjeri Woi-wurrung people, Kulin Nation in around Melbourne. This is not Wurundjeri land. This is a photo near the Prom, which is variously Bunurong or Gunai country, but it's where I spent a lot of my childhood, and I guess like probably everyone in the room has that special place, which is why they went into ecology and conservation. And then I also, later on, I have some photos from the Tiwi Islands I wanted to acknowledge their different clans and the people that of the lands that we worked on there. And just to acknowledge their stewardship of country and pay my respects to their elders and ancestors. In the context I'm going to talk about, I also want to acknowledge the extraordinary leadership at the global level of different Indigenous peoples groups and local community groups in the UN Convention on Biological Diversity negotiations lead up to the GBF. So previous Convention on Biological Diversity goals and targets had minimal or no mention of Indigenous people. Even the SDGs, which are sort of heralded as this all-encompassing approach to sustainability, only have Indigenous people mentioned in the preamble. They're not in any of their goals or targets, so pointed out as particular rights holders or knowledge holders, whereas the Indigenous peoples groups in the CBD negotiations have them embedded across, many of the targets included in the indicators that countries have to report on. I think that's quite an extraordinary shift, and it's really due to their leadership. So a lot of my talk today is going to focus on the Montreal Global Biodiversity Framework. I don't know how familiar people are with it and how much I need to skim over. Hands up if you know by heart exactly what target it's about. Have an inkling? Okay. So it's the latest set of decadal goals and targets under the UN Convention on Biological Diversity, which was one of the Rio Conventions established in 1992 by the United Nations, along with the much better known UNFCCC, the Climate Change Convention, and then there's another one which is like the littlest sibling, most often forgotten on about desertification. Like the UNFCCC, there's sort of these decadal cycle goals and targets that all the countries sign up to, like the Paris Agreement, the Kyoto Protocol, and so we have these targets and goals, of which the GBF is the latest. So it's the main multilateral agreement for nature. It has 196 parties, including Australia. Parties being countries or large organisations. So one of them is the European Union, as well as each of the individual countries. It has the GBF has 4 goals that relate to sustaining nature and ecosystem services, sharing the benefits. Then 23 targets, which are really focused around actions to achieve those goals. So they actually do quite a good job of separating out the overarching goals and then the targets that you need. And I think this is all pretty good because it's all done by negotiation. And so if anything good arises from it, it's a bit of a miracle, but it was really quite well done in the end. For the first time, as well as this sort of clear delineate separation of goals and targets, so like the means and the ends, they also had a monitoring input, agreed on a monitoring framework to track progress. And it also provided essential data to support the implementation. And this was particularly the headline indicators. So there's a larger monitoring framework, and part of it is these headline indicators that all the parties have agreed to and that they should use to report sort of every 5 years on their progress towards the goals and targets. As well as this sort of better structure around the GBF than previous targets. So the previous ones called the ESG targets. You might have heard of those. They also had a much stronger ecosystem approach across the GBF than in the previous set of targets that was really consistent across different types of ecosystems. The ESG targets had targets for coral reefs and forests, but not all ecosystems, for example. And so this is expressed in goal A, the outcome goal that we need to basically improve the quality and area of natural ecosystems. Goal B is that we maintain the benefits that people get from ecosystems. Then there's a whole lot of targets that address these ecosystems, that address ecosystems like restoration and protection, ecologically represented protected areas. And then associated with these, there's this set of indicators that relate to ecosystems. And these, as a set, have the potential to be quite powerful. So, for example, A1, the red list of ecosystems, which is one that we developed over the last 15 years, that tells us how many threatened ecosystems we have in a country. A2 tells us how much natural ecosystems you have left. B1 tells us how's the flow of services from those ecosystems. 2 tells us about how much we're restoring. And 3.1 tells us about how much is protected for different types of ecosystems. So you could say, how much are we protecting of mangroves, for example, restoring of mangroves, how they're faring, what's their trajectory, how the benefits we get from those. But the benefit of these as a set only comes if we report on them consistently across the different indicators and across countries in terms of the classification of ecosystems or an agreed set of indicators and the way that we report on those. And as the expert group on indicators, we recommended the global ecosystem typology as the approach for doing that, and that was adopted by countries after quite a lot of negotiations that were really frustrating during the COP16. So I am a co-author on the global ecosystem typology. So it's like not a conflict of interest, but just to declare that. And so the global ecosystem typology was led by David Keith under IUCN's Commission on Ecosystem Management. And this is an approach that can really support consistent reporting, so I said across indicators and across countries. It doesn't replace national data on ecosystems, that's a really important point to make, but rather allows us to harmonise national data sets by cross-referencing to these broad ecosystem categories. And that's what these little red ones are, like your national ecosystem classifications, and they can be associated with these different ecosystem functional groups, which are these I'll tell you what they are in a moment, these very broad ecosystem classifications. So it's a hierarchical system. So we can harmonise existing data to it, we can use it to structure new ecosystem classifications. So for example, in Myanmar, many of you might know Nick Murray, who was a postdoc, a PhD student postdoc here many years ago. He did a red list of ecosystems in Myanmar and developed an ecosystem typology. And that for there, and they used the typology to structure that to make sure they had it as comprehensive and they're globally consistent. And it's also has seen a lot of uptake. So the UN Statistics Division adopted it as into the International Family of Statistical Classifications, along with mung bean, or different types of beans and different labour type, different job types. It goes in that slightly dull but very important, consistent set of library of tools. It's also been adopted by IUCN. You can read about it in a Nature paper and also on a website, which I'll show you in a minute. So these are the sort of categories we're talking about. We've got 110 ecosystem functional groups. 18 of those are anthropogenic, like plantations, cities, so forth. And so that leaves 80 something, 90 something, like that's not very good, which are sort of natural ecosystem types. And they're very familiar. So subtropical, tropical rainforests, mangroves, sandy beaches, lowland rivers. So these are not unfamiliar categories of ecosystems. They're very broad levels. Obviously, you get you can break that down into fine ecosystem classifications. So for each of these, we've got like a one-page description, indicative distribution, a conceptual model of what makes this ecosystem tick, like what are the key drivers in this ecosystem, the key characteristics, photos and so forth. And just to give an idea of going into detail on one of these, this is the pyrrhic tussock savannas, which occur worldwide. Across these different, so here's examples. It occurs in Brazil, Northern Australia, Southern Africa. Have very, very few species in common across these different parts of the world. But the key traits of that ecosystem are similar. The key drivers, it's basically driven by seasonal, subtropical, monsoonal rainfall. The grass grows loads, dries out, cures, burns, and that's the key driver. There's trees to varying degrees, so you can see, like in not very tree, very tree, and that deals with other things like rainfall gradients, but they're not the dominant driver of these systems. It's this grass fire thing. And here's an example just with different ecosystem types within Australia. So this again, Tiwi Islands, work that Alice Young did. These are all different savanna types, and they've got slightly different composition, different dominant trees, slightly different structural element. But the key thing is this grass. This one hasn't been burnt for a couple of years, and this one's been burnt more recently and is drier as well. So there's these gradients, but you can see that as you have different ecosystem types within an ecosystem group. Okay. So how do we use these to report in on the headline indicators for the GBF? So here's some indicative data from Colombia, which mocked up from their red list of ecosystems assessment. So there's 3 indicators: red list of ecosystems, extent of natural ecosystems, and the proportion of the different ecosystems under protection in the protected areas. And what can you get from this that is sort of more than the sum of the parts? Well, you can start to see patterns because each of these rows, or stacked charts in this case, stacked columns, are different ecosystem functional groups. And so you can start to see patterns emerging. So for example, for tropical dry forests, they're all critically endangered. That's what the red is here. Very high red list index for ecosystems, or very low, sorry, like near 0, 0.2, because they're all critically endangered. And this is largely driven by complete loss of area. There's virtually nothing left, so like 5-6% of the original distribution left. About half of what's, you can't really even see because it's so small, about half of what's left is protected, which is 3%, 2% of the original distribution. And some of that was protected after they did the red list of ecosystems assessment, and they realised how threatened they all were, that they started to establish protected areas. And if we contrast this with lowland tropical rainforests, we can see about half of them are threatened. That's also not good, but slightly better than the dry forests. We've seen some loss of area, but it's not as dire. So this means that something else is driving its threat status. Loss of function, for example, change in the key biotic processes, or environmental degradation, change in rainfall patterns, fragmentation. And we're getting close to the 30% of the original extent protected. So that's the goal the target is 30%, which is great. Still, you could protect more. and science tells us that we need to maintain something like 80% of the Amazon. A lot of this is in the Colombian Amazon to maintain global climate systems. And of course, this tropical dry forest, critically endangered, and they little critically endangered critters then as well. What they're called.
Not a bird, so
Yeah, so that's the red list index, which is a value for summarising across all the risk status. which is annoyingly what it looks like we're going to have to report on instead of the raw data. It is called an emperor tamarin. I think white cotton top tamarin. The emperor one's the one with a massive moustache, like an old emperor. So just to dive into some of these indicators a little bit more. So the one that I've been working on for the last 15 years or so is the red list of ecosystems. Again, David Keith led all of this work, so it's Australian science to establish these criteria for assessing if an ecosystem is threatened. And then the work on the indicators, those dots that Matt pointed out, that was those were developed by a PhD student, Jess Rowland, during her PhD with me at Deakin. So the red list of ecosystems basically synthesises all our knowledge about a given ecosystem or set of ecosystems. So you get, maps, descriptions of their characteristic biota, diagnose the threats, we often draw a conceptual model to understand how the system is threatened, compile all the data that we have on change in area integrity of that system or degradation of that system. We then assess that against fixed criteria with thresholds. And so these criteria relate to change in area and distribution, measured over different timeframes from the long past, recent past, and into the future. So you can use like climate change projections, for example. And then from these, we can allocate ecosystems to different risk categories. And these are very familiar risk categories for anyone who does the red list, uses a red list of threatened species, or takes their kid to the zoo, see the signs, telling us how threatened different species and ecosystems are. And that can be mapped. This is from South Africa, a map of their threatened ecosystems, basically. And they assessed all the ecosystems, marine, terrestrial, freshwater. And from those different threat categories, we can derive this index that Jess Rowland developed. And it's comparable to one of the other headline indicators for species, which is a red list index of species survival. And you basically compute it from the number of ecosystem types per risk category in each ecosystem functional group to give you that plot from here. And this just learned last week that we can't be able to report this, and so then we can't make a global indicator from data the countries are going to submit. So I'll have to email them to get it. But if you have this data, you can then calculate a global indicator as well to say how all mangroves around the world fare, for example, or coral reefs. And then if, like South Africa, you've done multiple ecosystem assessments, you can track how your ecosystems are faring through time. And so there's only a small change across all ecosystems, but we see some which have seen a huge decline from like 0.7, which would mean that, a fraction, a minority are threatened, a really big shift. And this is a coastal ecosystem group, coastal shrublands and grasslands, which are risk of development, invasion. One of the other headline, or two of the other headline indicators that come from the fact that relate to ecosystems, both come from ecosystem accounting, which is using the UN Statistics Division's international standard for ecosystem and natural capital accounting, the CAEA, and ecosystem accounts have extent accounts, condition accounts, and then a few different services accounts that measure biophysical ecosystem services or benefits, and then monetary. The extent accounts give us an indicator is ecosystem extent, and the services, the biophysical service accounts gives us an indicator B1 on services provided by ecosystems. And these, again, it's all recommended that you structure these using the global ecosystem typology and report on those. And I've just highlighted the ecosystem condition. That's not used, and it's not, there's no headline indicator for ecosystem condition or integrity, though it is kind of embedded in the red list of ecosystems. I'll talk a bit more about that. How's the data coverage for these? Patchy. So on the top here, we've got the red list. This is data availability for the red list of ecosystems. So the dark red countries have got all their ecosystems assessed, like South Africa. And you can see there's a fair few countries that have done that. Red or pink is where there's a subset of ecosystems that have been systematically assessed. So there's a big assessment of the forests of the Americas, for example, that assessed all of the forest ecosystem types. From these, we can develop a red list index by country, but this is an overall one So you can see which countries have got more threatened ecosystems than others. What you'll notice is there's a bit of a gap for Australia, with all these dots, and that's David Keith's prolific work in doing red list of ecosystems assessments through his networks. But we haven't got a national red list assessment. This is similar data from Ecosystem Accounting. Australia just published its most recent set of its first ecosystem accounts a couple of months ago. You can see it's pretty similar patterns of which countries have got accounts on red list of ecosystems. I think it says something about where we have data on ecosystems, and there's been investment in ecosystem mapping. And a new work which is being led by Nick Murray, for those who know him again, is this Global Ecosystems Atlas, which is aims to provide high quality maps of ecosystems at the ecosystem functional group level for the whole world. And that the one intent is to support ecosystem accounting and red list of ecosystems assessment. And that works underway. So there's a prototype that was developed for COP16 for the left. Okay. And so what we can, from going into a little bit more detail on those indicators, we can see that there's some key foundational data that countries need to be able to report on them. And these are to have a typology of your ecosystems and descriptions, so you know what you have, like having a list of species, maps so we know where they are, and then these indicators of integrity of those ecosystems, so how, or some others refer to as condition, depending on which world you're moving in. And these data underpin ecosystem accounting as well as red list of ecosystems. The same data can serve both if they meet certain qualities which particularly relate to measuring characteristics of that ecosystem rather than general condition maps or something like that. So that's something to talk about. And these feed into these headline indicators. But the same data are needed for key biodiversity areas, which also feeds into headline indicator 3.1 objective areas. And a really important emerging use that also relies on ecosystem extent and all this foundational data and risk and key biodiversity areas of these private sector frameworks, TNFD, the Task Force of Nature-related Financial Disclosures. I can't remember what the other acronyms are, too many acronyms. And these are really driving, I suspect they're going to drive a lot of data acquisition and analysis, but where those data are going to drive where developments happen, and where we don't have data, the developments may go unchecked because absence of knowledge is treated as an absence of values, which is a bit concerning. That also feeds into a target in the GBF as well. So just to sort of, I've talked a lot about the value of this foundational ecosystem knowledge on area integrity and risk, or ecosystem maps and classifications as well, for reporting on the GBF and the different headline indicators. But it's also, these data are foundational to implementing all across many of the targets and goals of the GBF. And we did an analysis of how these information could be used. So for example, ecosystem maps, spatial data on integrity and ecosystem descriptions are essential to implementing a whole of the other targets. For example, you can't really know what to restore, what actions to do in restoration, unless you understand what ecosystem types are there or should be there. Similarly, spatial maps are really key for spatial planning when you're deciding what to put where you might develop, and where you might protect. Risk categories, like how threatened things are really essential to prioritising, while the threat diagnosis process can tell you why an ecosystem is threatened. So for example, it might help you decide where to act on pollution. If an ecosystem is being threatened by pollutions, then different types of pollution, and you know what triggers you need to do to manage that potentially. And of course, it's really key to prioritising where to protect. In the example of Colombia, where they protected their threat, they're critically endangered dry forests. And one of the lessons from South Africa was just how important these maps of threatened ecosystems were in terms of mainstreaming. Like government departments love them for some reason. I said that was one of the key messaging things, was just having these maps where you could see where the threatened ecosystems are, and that now underpins a whole lot of their legislation. And then finally, when you're using these consistent frame standards like the Red List of Ecosystems or typology, also ecosystem accounting, you get this really consistent set of definitions and criteria that allow you to work together and build capacity and build knowledge. So this is an example of a workshop in Kenya, in Mombasa, when they were starting their Red List of Ecosystems for coral reefs in the Western Indian Ocean. And they invited scientists like Louise Odunga, who worked on the Red List assessment of kelp forests in South Africa, to share his experience, and then also scientists from Malawi, for example, who are embarking on their Red List ecosystem. So it's really enabling this collaboration. Okay, so now I'm going way over time. What's happening in Australia? We have our strategy. Looks a little bit more like a beautiful brochure, potentially, than a substantive national biodiversity strategy and action plan, but it's better than the last one, which had very little substance in it. We've signed the agreement, but in that action plan, we really only have 13 of the 23 targets that are highlighted, and only partially. And so there's 7 action targets, but it's sort of a little bit cherry picking the bits that we want. So we love the protected area target because we've already met it, or largely met it, mostly through Indigenous lands. How far off are we?
Well, only the area part.
Yeah, exactly. That's what I mean. So they cherry pick the area bit, not all the other qualitative statements in the target. Again, some of the enabling targets about mainstreaming and things like that are only sort of partially picking up bits of them. We, in that plan, didn't commit to reporting on the indicators, though talking to people at DQ, they are committed to reporting on the indicators, but a lot of these headline indicators need quite a lot of investment. So we'll have to see how that actually eventuates. And surprisingly, we have low data availability and reporting capacity, even though so much of the science came from Australia. So when we go to report on those headline indicators, how are we going? Well, Red List of Ecosystems, we do have we have legislation that deals with threatened ecological communities federally in most states, but we haven't got a national map of, like South Africa does, of threatened ecosystems. That's the EPBC map of the EPBC listed ones that Henley Grantham shared. That's some of the Red List of Ecosystems assessments that have been done by David, as had the black dots in the previous map. We have a map of ecosystems based on NVIS that was put together as sort of quite hastily put together for the ecosystem accounts, but it's a good foundation. And David Keith has got an industry laureate to revise that and really develop a really strong hierarchical map of classification and map of the ecosystems of Australia. So that's well underway. So we can report on that now with some basic data, and that'll get better. The Red List Index for species survival, we have it for vertebrates, not so good, like only 40% of our plants have been assessed under the Red List, so it's a bit lacking in data for a lot of groups. We have the one of the complementary, not the headline indicators, a version of it with the Threatened Species Index, so we'll be able to report on that. So we're doing better on the species, but just at the headline indicator level, a lot of gaps still. Protected areas, we've got pretty good data on the quantitative elements, percentage protected. They're not quite there. Yeah. But we do things like make a massive protected area, marine protected area where there aren't any people. And that's how you can easily get above whether it's managed effectively and all those other clauses is the other question. And then rate of invasive alien species, again, there's data around another Australian-led indicator, but it's not sort of sitting there, it needs to be worked on. what's the uptake? So the ABS is really focusing on those ecosystem accounts. So that's going to be a real driver of ecosystem data. They didn't really do condition accounts. We've seen the red list of ecosystems protocol in principle has been adopted as the method for listing ecological communities under our legislation. It's not actually been implemented yet, except in 3 states, in WA, New South Wales and ACT. Everyone else has agreed in principle, but they're not doing it yet. So we'll see if it actually ever happens, hoping that it will. And then this is, the government loves these. So they're a big supporter of TNFD. They really like the idea of private sector investment and nature repair market and all this sort of stuff. And so we'll see that might drive investment in the necessary foundational data as well. We'll see. So where are we? As I said, we're making progress on the National Ecosystem Typology Descriptions Map. So that's the blue bit up there. But one of the really big gaps we have is ecosystem-specific indicators of integrity, which are the type that are needed for all of these, actually, these uses. What we have is generic, or what I call ecosystem agnostic indicators. So they things like HCAS and other sort of general indicators that don't really think about the ecosystem type and its characteristics, often using remotely sensed data, or it might implicitly include some of those characteristics. But these 2 needs really want you to think about how do you best measure the state of that ecosystem itself. An example of what I mean by that. And so it needs variables that you need to get the right variables that relate to that ecosystem, and then you need to tailor them to the ecosystem type. So, for example, in the accounts, they were not able to do this with the condition accounts. So we have on there like a little headline key statistics. They've got desert ecosystems make up 50% of Australia. It's interesting. That's a useful fact. Easy to interpret. Between over the 5-year period, 4% of natural environments adjacent to rivers were converted. Oh, that's an interesting, useful, interpretable fact. So we need to protect riparian and floodplain ecosystems better. More feral animals and weeds, that we know that that's not good. And we can interpret that. But this one, in 2021, half of Australia's mangroves had at least 80% canopy cover. Is that good? Is that bad? I don't know. Is that normal for a mangrove? Maybe. And similarly, they reported on these variables. So in this case, NDVI by ecosystem. So these are the different ecosystem functional groups. Each of those colours is a different year. And so what we can see is they're bouncing around a bit. Blue is 2010, so it's a little bit lower on most of them, just after the end of the drought. What we can see though is that they move a little bit, but the differences between ecosystem types is much bigger than the differences on average in year within an ecosystem type. So how do we interpret that? So I think we could probably say in rainforests, it's better to be greener, more productive, but in grasslands, this might mean shrubbery or weed encroachment. So actually the direction, not only the values, but the direction of change is going to mean something different. So we need to be able to turn these variables into something meaningful by tailoring it to the ecosystem type. And it could be that it's actually completely meaningless to have this indicator, like for sandy shorelines, productivity. Is that like the amount of seaweed sitting on the beach? I'm not sure. So you probably wouldn't even bother to do that. So that's what I mean, like making proper indicators of ecosystem integrity. All right, so other challenges. There are many challenges about measuring ecosystems and developing ecosystem indicators. One of these is bringing together different knowledge systems for classifying, describing, mapping ecosystems, and what change means. What is good and bad change in those systems? We've started to try and go down to just touch on that a little bit and work with Alice Young, who just submitted her PhD 2 weeks ago, working on the Tiwi Islands, where we worked with Tiwi rangers and people and knowledge holders to go out the country, understand what they try to understand, and get a taste of what they call the ecosystems, how they perceive them, which ones they consider the same or different, and how they use them. And that fed into her ecosystem mapping, combined with global ecosystem topology and other data. And those maps are now, interestingly, so that was work with the Land Council, and they're actually using those maps to help delineate plan boundaries, which is really interesting, which I think might have followed vegetation boundaries. One of the other challenges is just how we use this information. So how you get this structure in decision making, information about species, ecosystems, threatened ones that are changing, particularly when we're talking about private sector reporting. So making sure that the frameworks and the rules around how you use that information to make decisions and where there are go, no-go zones, for example, are most effective to protect biodiversity and sustain ecosystems. In Australia, we have a lot of other challenges of cross-jurisdictional data and responsibilities. Everyone's doing something slightly different, with different priorities, different needs. We have until now had a sort of a lack of a coherent ecosystem classification in Australia, but luckily David Keith's working on that. And what we definitely have is a lack of this sort of coordinated, coherent or consistent biodiversity monitoring framework. And I've got a grant in on that at the moment, so hoping that will get up. So that'll be an interesting challenge. But yeah, as I said, every state federally doing their own thing. They shouldn't all have to do the same thing, but at least those systems should talk to each other in some way to make the most of all that data that is being collected. So just take home messages: ecosystems are important, they matter, and they're central for the GPF in Australia and globally. And that this ecosystem data and knowledge and indicators can help monitor progress, but also guide action. I think that the guiding action is more important than a lot of progress, to be honest. But with all these data gaps, there's a high need for coordinated data training and collaboration in Australia and globally, and also investment in that. I'd hate to be the person who goes, we need more data, we need more money in this, but this is sort of an area, I think, where there's a high reward for investing that countries like South Africa and Malawi is the center members of ecosystems, and we have it in Australia. That's one of the poorest countries in the world. And one of the big challenges is going to be how we bring all this data and knowledge together, particularly the private sector use, to ensure better outcomes that we've seen. And I think many wonderful people, there's more there, but not.
That's it. That's really.
Are the typology data layers publicly available, or are they just used for assessment?
No, yeah, they are. They're indicative though, so some of them are better than others, and they're not mutually exclusive. They're one by one. And so, if you were to go to somewhere that had no ecosystem map, then you would probably deduce what you've got that have those options, and they're indicative, so they're not 100% correct. But for example, Queensland's regional ecosystem data is all being crosswalked with the typology that's on the atlas, readily available. But for other parts of the world, not so much. But there's work underway, like Malaysia's to be mapping their ecosystem and renders of ecosystems.
Thank you. That was so awesome and so impactful and such a huge fan. What you said at the end there, like the just listing of information, which is fine, but doesn't really tell us whether things are good or bad or how close to where we're going. I completely agree. But also it made me think about even the headline targets around extent, for example, also doesn't seem to really be framed in the way we need it. Because it would seem to me the way it should be is what fraction of your ecosystems have, substantially greater extent than 2020. That would be the way you'd frame it, so you can track relative to the benchmark, which is where you're trying to get to, which is the substantially greater extent than 2020, right? And then why would they not report it in that way and instead just lump collectively all the ecosystems and say, here's the extent? Because you still need to do that interpretive work to work back to, and therefore how are we going against the goal?
Yeah, so for the extent of natural ecosystems, we're encouraging people to report back as long as possible. So if you've got data from 1900, report that as well. Give us a complete time series. And by ecosystem functional group, still very lumpy. And then you're meant to have 2020 as a bit of a baseline, but I think it's going to be whatever data people have. And then the question is, has it increased? So it's not asking for what's net over given ecosystem functional groups, net change, but it's not going to tell you how much you've lost of any group. It's there might be. I mean,
It's just sheer extent, right? And you interpret that
kilometers
to mean each, like all ecosystems. You mean each ecosystem. Is that how you interpret the word all in that goal, or do you think all collectively?
No, I interpret that to mean you need to measure for all your different ecosystems.
Yeah, so each of them has to achieve that increase.
Oh,
That's what, the way the goal is worded.
yeah, increase. It's very hand wavy.
It's very hand wavy.
Like they didn't want it to be too specific, but also they want it to be kind of elegant, aspirational. We want to increase in the extent of natural ecosystem.
So it says all,
and
and that's
all,
probably what's encouraging the lumping of the data.
Yeah, the all is really about not is saying that we want across all our freshwater, marine and terrestrial. That's what it's shorthand for.
Oh, so you can lose your rainforest entirely as long as that's counterbalanced.
No. But that you're. I don't think they thought that much about it. But what it was is more encompassing. It's like you can't just focus on coral reefs.
It's just so frustrating because until you understand what the actual goal is meant to mean, how do you derive an indicator for?
Well, I think the indicator actually, so the way that I've seen it is the goals are very hand wavy, right? So that they didn't we want to put risk of collapse in the goal for the ecosystem. They put resilience, increased resilience, as opposed to risk of collapse are pretty negative. But then they pick a headline indicator that measures that thing. So I actually take the headline indicator as being telling you more about what the goal is. You use them in tandem. So the headline indicator for extent is basically the amount of each ecosystem functional group reported by kilometres squared or whatever through time. And so that will tell you if things are on an upward or downward trajectory.
Yeah, which is the actual goal, is the upward trajectory part. So why don't they just directly say that is the headline?
Because then we can actually analyse that data.
I mean, you can, but it feels like it's sending you back to do the work, just like you said with that list of things. You've got to go back and say, okay, well, what was it in 2020?
Yeah. But then you can analyse it, you can go above things. Actually, it'll be interesting to see what they actually are requesting to report, because we're now just finally going from what we wrote as the guidelines for what the indicator should be to now we're asking governments to report. It's quite different, which is annoying. Anyway, sorry, there are lots of hands.
Sorry.
Yeah.
I have two questions. Like one, just a really quick one.
Yeah.
Which is, you reminded me just then. So you say like they're deciding on headline indicators and making decisions now outside of the CBDs. I've always wondered is it like smaller UN groups in Geneva are having conversations about headline indicators when you say they?
Oh, so it's the Convention on Biodiversity Secretariat.
Okay, and they have like regular.
Yeah, and so they're contacting us as the indicator developers, and also all of us work on the working group for indicators.
And then my other question was, what feeds into the kind of higher level data? So when you say South Africa's done a full assessment of their ecosystems, what are they actually doing? I mean, I'm guessing it's like remote sensing data of extents, and then is it qualitative assessments of quality, or like what?
Yeah,
what's the precise thing into it?
So it varies. So in South Africa, they've been mapping their ecosystem since the 90s. So really early, very detailed botanical work. A lot of it was led by Richard Cowling and others. So they're real like botanists. So if you look at the map, their map of the fine moss, for example, they can see it's like super fine scale down here. It's just pixelated, but very, very, very detailed, very ecologically driven. They have it's hardwired into legislation, so it's got to be right. They have all these mechanisms for updating it. It's really, really detailed. Their most of their red list assessment is as it relates to area, and so all this area is red because that's where all the urban development is. They don't have much condition data, so it can be inference. So for the red list of ecosystems, you might have long-term data for certain sites. So from that, you infer what invasive species spread or whatever, and then from that, so you don't have to have really hard data. It's about trying to infer risk. Colombia took a different approach. They've modelled. They picked out something like 90 pairs of pollinator animals and fruit disperser animals, and then paired them all up, and then modelled decoupling, risk of decoupling, and changes in distribution, and that's what they use to measure their change in ecosystem function for their integrity metric. Also climate change projections. So it varies, and then you have this sort of standardized framework for what you can assess, but the actual data would be different depending on what's available.
Thanks.
So, no.
Thanks, Andy. I'm kind of interested in the probability of collapse. How much nitty-gritty goes into that? Is there detailed models behind it? From my reviews of land modeling, you can go to alternative state is just the land that's changing.
Yeah. You mean like this one here?
Yeah, that's
Yeah, and so these ones are really broad categories. So like change in distribution, if you've lost more than 80% of your distribution as an ecosystem in the last 50 years, you're critically endangered. But this one, the probability classes, we use a stochastic ecosystem model. We did that for, there's only a handful of them that have been done. Coral reefs was one, where we picked up a coral reef model and just ran all these simulations under, it was modeled to different purpose. And it didn't, well, things would, the ecosystem, the coral would like descend into rubble and it would be collapsed. We didn't have the alternative states of, say, savanna forest. You could use the model like that. You want to do it?
sure. Yeah.
Yeah. That's actually what we've been talking about a lot, because there's other systems that have those different states as well. Fire-driven retreat of land and then aggression.
It's really interesting work. I'm wondering, there's some governments that their legal protections for biodiversity are really focused on species. And then I'm just wondering what's sort of the interplay between this work and sort of those laws, and if this is going to be sort of more driven into a lot of countries' laws for biodiversity protection.
Yeah. Excellent. I've got a master's student starting next semester to try and review it all, because we actually don't know. So South Africa, for example, their threatened biodiversity legislation doesn't include species, only ecosystems. And then in Australia, every state has threatened species legislation. We do have ecological communities, but they're kind of, they've only assessed 100 in federally in Australia compared with thousands of species. So it's really on the back burner and not a priority, and very underdone. I suspect that is almost a decision because, so for example, in Victoria, we do have mechanisms for threatened ecological communities. We don't use them. It's partly because 80% of Victoria is cleared, so you'd have a lot of threatened ecosystems. It would constrain stuff a lot. Even those that we have that are critically endangered, threatened grasslands, grassy woodlands, still there's decisions about trade-offs. So where they'll develop them or just let them degrade. So I think that there's probably some, there in many cases, some reluctance to use it. But in others, so like in Chile, that was done, the release of ecosystems was done by academics, but then picked up by the government subsequently. So you see very different, and same in Finland and Norway, very government driven, it's a bit more like a South African model. So it really varies. But something we're really interested to know is how it's used, and therefore what's successful, and therefore what new countries who are doing it. So for example, Peru's just wants, and Argentina want to do their release of ecosystems. How could they use that in their legislation to get better outcomes? And that's something we need to understand better.
Follow-on question from Matt. And you talked about it's a social question about not just the legislative opportunities for the data to be used, but I guess how the professionals working in those settings interpret and value and use data. Is there any research about the journey? Like, we know that data has a diverse journey to impact, but you talked about how South African, the peeps there loving the maps and they're quite influential. Is there much research about how the different types of indicators are getting interpreted or valued or used?
No, so there's two really interesting papers just for the red list of ecosystems. One from South Africa on all the ways that they use it, but it's not social science research. And there's one from Finland, which is actually social science research, where they interviewed the people who were involved and try to understand how that sort of said it has this transformative potential, but it's not met because of these constraints, particularly around forestry in Finland. Really interesting paper though. If you Salama, I think this is the name of the person who did it, but these things are just starting to emerge as normally after it's been in the country for quite a long time, like over a decade, 15 years, embedded in their legislative frameworks or becoming more and more publicly known as well, like when they do the readiness assessments and they do a big public aware, like in the media, and there's so many people are aware that we have threatened ecosystems or habitats actually in Finland, then that changes the narrative, and that's quite a recent. Those stories are only just coming out now, I guess, in hindsight.
Yes, a question online from Natalie Frost. How long would it take and cost to get Australia's data and monitoring metrics improved and more suitable for accurate monitoring to meet the GBF's targets? Is Environment Information Australia actively looking into this?
Yeah, so I'm working with them a little bit. So the GBF monitoring framework was agreed at the end of 2022. And so it's slowly, I guess the government's been coming on board. So they're just now starting to think that to commit, but just it's slow. So maybe they need to wait for the election cycle, I don't know. They're not going to invest anywhere near as much as it's needed, put it that way. The development of the readiness of ecosystems, all the assessments that have been done, now the global ecosystem typology and our David Keith's work mapping that ecosystem of Australia, that was all done on ARC grant money. But each of the states has got their national vegetation map, or regional ecosystem maps, or state vegetation maps, which is like decades of investment as well. And so David's really building on that data to develop a national hierarchical system. It'll be pieced together somehow, and it'll be not quite adequate. But I think as we, like, I sort of think of this in the long game, like you're trying to set up a monitoring system that won't be ready for next year when the first GBF reporting is, but probably not even for 2029, which is the next GBF reporting. But you're slowly building up to something that works over the longer term, and hopefully we get this really slowly.
Okay, very interesting. So I was just wondering how this information about the red list of ecosystems is related to the red list of species.
Yeah.
And like, I don't know, like, do they coincide the ecosystems at risk with the distribution of threatened species? And how this information the combination of this information can actually inform policy and decision making about should I, like, because maybe there are some trade-offs in investing in one direction or the other.
Amazingly, we haven't done that yet. Something we've been talking about, and I've had it there as a project for PhD students to do, but for some reason they're not, like, it doesn't sound interesting enough for them or something, I'm not sure. But it's a fascinating question. I mean, you could test that with South Africa, for example. A lot of them are going to be driven by similar things, habitat loss, but it will depend on the drivers of change. So things like, so for example, in Australia, the complete lack of mammals across much of Australia would probably come up under sort of loss of integrity of ecosystems. But you wouldn't say that, I don't think you would say that all of Australia's deserts have collapsed because they no longer have small mammals. You'd say they're degraded, like they've lost, for example, in Victoria, but nothing, what kidneys are still doing a bit of digging, but you know, when you go to somewhere like the Tiwi Islands, you're rolling your ankles all the time because there's so many bloody bandicoots everywhere, digging holes everywhere, and they're turning over the soil. You just don't get that in Victoria anymore. But you probably wouldn't say those forests have collapsed. They're severely degraded or something like that. So you would get different patterns depending on what it is that is driving it. But I'd love to. I think particularly important for guiding decisions, or rather, how do you use this information together? I think is the key question, I think.
One last question.
Last one.
Off the back of the online question, with getting enough data, do you know, is there any, I don't know the situation with the nature repair mark well enough, but is there any laws around kind of trying to get data from that fed back into the public sphere so that it can be used?
Yeah, in Western Australia, they've set up a system where private sector, like consultants data, needs to feed back in, and they've got a setting up a biodiversity portal to harness all that data. I don't know if in the other states have got it to the same degree. It'd be really good. Like even just surveys, like when we were working on the Tiwi Islands, we had all that data because the Land Council held it all. And then we could use that in our ecosystem mapping and threatened plants and things like that, where they've done surveys for roads or something, but they have details on all it. But otherwise, you don't normally have that data available, which is just a terrible waste because billions of dollars anyway go into that every year.
So
Whether that's something that governments can just mandate, like.
do you have a question, something? No. All right, well, you might wrap it up there. In that case, please join me in.